Hello, hi everyone. Welcome to this new session, new Code on Deploy session. Thank you so much for being here. So today we have a great guest. But before going to the guest, please, as usual, what we do all the time, please let us know from where you are watching us, even if you are seeing this offline. It would be great to know where you're watching us. So again, for those of you that didn't attend to any of the previous sessions, this is a coding session. So we'll be diving into the code, ideally no slides, just to present something, because sometimes we need to have some presentations to show, or some slides, or some diagrams. We need to understand what we are doing, right? Sometimes. But in case if you would like to see real coding, this is the best place. Will be 1 hour, 45, 50 minutes. We used to invite people from the community, or great people that is working with projects or creating something. In case if you would like to be here, also send us a DM, or to me, or to Open at Intel, and we can have you here as a guest, right? So all right, so before I think that we can start introducing my guest. In that case is Sujee. I mean, we know each other. We've been working in some projects with the AI Alliance. In case of you that are not familiar with the AI Alliance, is an organization which works multiple companies, but the main idea is to democratize AI, and to with a heavy focus on AI and open source, which is very important nowadays, because we need to leave the things to the open, ideally. So we work together on that. Sujee also does DevRel, so we share the same passion. So it's a real great to have him here, and he will be doing something great. But don't want to say what he will be doing. I would like to have him explaining that to us. So Sujee, you should be here. Hi, Sujee. How are you?
Camera on.
Yeah, Cameron, here we are. How are you?
Yes. Good morning, good afternoon, and good evening to everybody joining. I'm good, Easy. How are you, man?
Good, man. Good. Thank you for being here. Thank you for taking your time to come here and to have some fun. So before, I would like to know something about you for the people that don't know you. Can you introduce yourself? Let us know what you do, what you've been working recently, in which projects mainly you've been working. But mainly, we would like to know from you. I mean, who you are actually.
Yeah, absolutely. So I come from a software development background. Excuse me. So I spent quite a bit of time spending, doing work like big data, data engineering, and also AI. So when I say AI, I mean sort of the traditional machine learning, deep learning, because now when I say AI, everybody thinks, it's a ChatGPT. This is before ChatGPT times. So I've been in this space, but I'm honestly really excited where the AI is, how fast AI is progressing now. I know you can see, especially generative AI, there's something new every day actually. And keeping up with the news is almost like a full-time job. So what I do is, like I said, I come from software development. I also done a lot of training. So, I train a lot of people in data engineering, AI technologies. So now I'm focusing more on consulting side of things, and I also do quite a bit of developer relations because I love doing conferences, workshops, hackathons. I know, we did one together, and that's how we met. So yeah, so that's me. I am in San Jose, California. So right now, what's time it is? It's like 10 in the morning for me, and right now it's 65 degrees, or 18 degrees, Celsius. So it's a pretty nice day.
Oh, it's a cool day. It's a
So
cool day. Yes, I'm here in
yeah,
Toronto. We are still enjoying the winter, even if we are in the spring. We still have the sun. I mean, we don't have snow, but at least it's cold.
Toronto spring.
Oh,
Yes, I'm familiar with that.
it's it's pretty cold.
Yeah,
So
yeah,
tell me which projects you'll be mainly working with, because I mean we share the same passion about AI
yeah,
and trying
yeah,
to transmit to people how they can learn from that. It's even hard for us, so I can imagine if you are new on this, or if you like to start practicing a new
yeah.
project, it can be pretty complicated. So
It
in which
is.
project you are mainly working recently?
So right now, my focus has been AI, but I'm also a big open source fan. I've been using open source in the very early days of Linux, right? Where I don't know if anybody remember here, when you get a new mouse, you have to recompile your kernel so your mouse can work. so I've been using open source. I also try to contribute as much as I can. So especially with AI, I'm a strong believer. Open source AI is something, right? It actually elevates everybody up. Because imagine if everything in AI is proprietary, there's not going to be a lot of innovation, right? But so I think we are in a very thriving ecosystem now. Lately, I've been working with AI Alliance as a DevRel. And this is one of the projects we did for AI Alliance, and I want to walk people through it. I hope it's a pretty exciting project, and hopefully some of you audience can find it interesting. Yeah. So
Amazing. All right. Yeah, that's great. All right, let's move on to what do you be doing. First, let let us know what you will be doing, and so we can see your screen. Left. Or just let me know
okay,
if you'd like to give you
sure.
access so you can
Yeah.
share a screen, whatever.
Yeah. Am I sharing? I
You are
think
sharing.
so.
Yeah.
Let me know if you can see my screen.
Yes, we can.
And yeah, like I said, I like to keep the slides to minimum. I want to look at it a little bit more hands-on, but I do want to show a few slides to just to so you understand what we're talking about. I'm open to questions, and if you can let me know the questions coming through.
Yep.
Yeah. Okay. So whenever you're ready, I can get going.
Yeah. I think
All
yes. I
right.
will let you know if there's any questions, or also my questions. Yes, I will
Yeah, please. Yeah.
interrupt
Yeah.
you if there is any questions or something. Yep.
No worries. So I'm on the Teams page. So right. So right. So if you have any questions, just put on the Teams page, and I'll happy to answer. All right. So let me talk a little bit about this project. We call it AllyCat. I'll talk about how the name came about. So very quick intro to sorry, you can take a picture of this page. We will share the slides. You can take a note of the link. Those are the link to the slides. And we will send out an email with all the links. But if you want to take a quick picture or screenshot, please do so. And you can get in touch with me, email, Twitter, all the usual channels. We talked a little bit about my background. So I come from data engineering, AI, cloud background. That's my cat, by the way. He always photographs much better than I am. So I thought I'll include that. So what are we trying to solve? Like, what's the idea here? If you go to any website, most of them will have like a little search bar, right, on the top, probably. And you can search for things, but these searches are what I call keyword search. You type in a keyword, they give you a bunch of pages that match the keyword, right? Very simple, sort of like what Google does, right? You search for a keyword, they give you a bunch of links, and then you click on the links to find the info. Now, I think we can do better, right? Because now most people have used LLMs. So, like large language models are very powerful. They can understand what you're asking. So you can ask questions in natural text and get answers. So the project started as saying, why don't we implement a natural language search, very easy to use, so people can ask, just in natural language, and then the system understand what they're asking and give you the answer. So this is like a Apache website. So you can see I'm searching for something like streaming keyword, and I see like a bunch of links that has the word stream, right? Now, what we set out to build is more like a Q&A chatbot kind of a style. So here, right, I'm asking a question, you can say, right? So this is AI Alliance. By the way, just a quick shout out to AI Alliance. AI Alliance is basically a consortium promoting AI and open source. So I've been doing some work for them. And we actually wanted to implement a chat interface to query the AI Alliance website. So for example, if you go to the AI Alliance website, right. So you see, right? So we have a like a a website for that has all the information about the alliance, who are the members, but so the search is missing. So we want to do a search, but a little better search than keyword match, and that's how the project started. And so that's how the project AllyCat was born. So we actually wanted to do an open source stack anybody can take and deploy on their website. Anybody can use it to query a website. So because we didn't want to be just tied to an Alliance website, we wanted to be an open stack so anybody can use it. That's the idea. So now people ask me, how did you guys come up with the name AllyCat? so it's kind of, so the history was, so initially it was called Alliance Chat because we are chatting with the Alliance website, and we were like, that's not very exciting. Then it became like AllyChat, and then AllyCat, right? So and then so the credit for the name and the logo should go to my my coworker Dave Nielsen.
He created the logo.
So, anyway,
he draw the logo.
I'm pretty sure there's like some some AI tool involved. But yeah, so the credit should go to him coming up with the name and the logo. So we thought, hey, that's pretty catchy. AllyCat, it's pretty cute and easy to pronounce. So let's stick with that. So that's how the name came out. All right. So what does AllyCat does? From a technical side, think of AllyCat as a full stack that has multiple components. So think like Lego. So the way I like to think about this is like more like Legos. So we have, for example, what do you need to query a website? So let's say you want to talk to a website. What do you need? First, you need to download the website, the content, right? So we have a web crawler built in. And then we need to clean up the content because when you download the content, it's coming up in HTML. HTML pages have a lot of like scripts, trackers, like markups. We don't need all of that for our query. So we clean up HTML pages. Then this kind of gets a little bit more technical. So we are kind of creating like embeddings and chunking so we can search them effectively. And then we save them into a database. And then finally, we are ready to query them using LLM. Right? So all these steps are involved in getting this to work. So we wanted to create a stack that is very easy to use and has all of these things installed and configured for you. And I'll show a demo of this one pretty soon. So again, like I said, open source, right? Because Alliance is very strong in open source. So we wanted to make sure we only feature open source components, but you can plug in any other component you guys like. We really made it to be like a Legos, literally like Legos, right? You can plug and play different components together to suit your needs. So, and you can, again, you'll see the stack. Again, I'm not going to go through the entire stack. So for example, crawling a website, we use a data prep kit, a toolkit called data prep kit that's helping you deal with data. And then to parse the pages, we use Docling and so on and so forth, right? And we'll go through each of these later, but I just want to give you a sense. Each of these, everything we're mentioning here is open source, even the models, like embedding models and everything. Yeah. So the way I like you to think about AllyCat is it's a full stack, but you can sort of mix and match different components. Like for example, when you're crawling a website, we are using a data prep kit connector. It's an open source project, I've been working on this for a while, so I use it. You can also use, there are a lot of other web crawlers. You can use those as well, like Scrappy, right, and Sphinx, things like this. So as long as it gets the job done, you can plug them in easily. Now, how do we clean up the content? I'm using Docling, but there are other processes that can clean up HTML to like a markdown format, right? You can use that as well. And for embeddings and vector databases, I'm using Milvus as an open source vector database. We also support VV8, another open source database, but you can plug in again pretty much anything like you like to use. And finally, for the LLMs, I like to use Llama or Gemma models, which are open. So again, all of these choices you can mix and match. So how do we run this? There are two modes of running this. Let's say you want to just experiment. You want to say, hey, is this going to work for me? The easiest thing I'm recommending is run through Docker, right? So you can see I'm just a Docker run, and here's the Docker image. So we actually package the Docker that has everything you need, right? All the libraries, all the services installed and configured. And when you run it, right, it downloads the Docker and starts up, and you can start with crawling the site, indexing, and so on and so forth. If you want to develop for it, like for example, you want to change code, right? You want to try different models, things like this. Then what we recommend is using Python to run it. Again, very simple. Like just we do pip install our requirements and then start running. That's it. So two modes, depending on your use case. A lot of people find the Docker easiest to use because to use Docker, you don't even need to set up Python on your laptop. I'm pretty sure most of us do. But if you don't want to set up the environment, you just want to say, hey, I just want to try this out. Try the Docker, right? Very straightforward. So what does it do, right? So underneath, I want to give you a little idea of what happens behind the scenes when you do this. So this is sort of the overall workflow. So imagine you point the AllyCat to a website. It's going to go and download a bunch of pages, right? So when the pages are coming down to us, they're coming in HTML format. Next step, what we do is I sort of convert HTML into Markdown, because this way, we can clean them up very easily. I don't have to have excessive markups, scripts, and trackers, all the stuff. So all the stuff is cleaned up. So now we have, simple, easy to read text. Then what we do is we sort of split them into small pieces, right? It's called chunking. The reason we do this is like, imagine you have a pretty big page. I'm just making this up, like 100 pages long. It's kind of inconvenience to search that. So, but if you split them into small chunks, then it's easier to search. So we do the splitting, right? And then finally, we so what we call vectorizing. Vectorizing basically meaning we are creating indexing and into embeddings. Why? Because they're easy to search. And also the embeddings are important when we do natural language search, because when you ask a question in natural language, not just keyword matching, embeddings is the technique we use, and this is what a lot of the LLMs use to find the pages we are looking for. And after all that is done, they just go to a database. Right? So at this point, your data has been downloaded. Right? So imagine like a pipeline. It sort of went through all these steps, and finally, it's in a vector database. Now we are ready to query. So when you run the query, like for example, let's say, what are some of the projects, right? So what we do is we actually query the vector database. Vector database gives me matching documents. So I don't have an answer just yet, right? All I'm getting from the vector database is documents that have the answer. Then we send that to an LLM. So the LLM reads the documents, looks at my question, and then figures out the answer, right? So the way I like you to think about is think like in the sort of the original Google search, right? When you do original Google search, when you search for a keyword, they give you a bunch of links. So then you have to go to the link, each link, read, and then kind of find your answer, right? So that's kind of what the LLM is doing now. So the vector database is giving you the top results, and then we send it to the LLM. So sometimes people ask me, why do we need a vector database? Why don't we just use the LLM directly? You can, right? I mean, so that's a very valid question. So the way I think about this is, imagine, let me say I have 1,000 pages. I'm asking a question about, say, projects. Maybe only about 3 pages have the, talking about the projects. Now, I only want to search for 3 pages, right? I don't want to search through all the 1,000 pages to find my answer. That's not very efficient. So when I ask the question, like, what are the projects people are working on, I actually want only the relevant documents that talk about the projects, right? And that's what the vector database is going to give us. Because now the LLM only gets 3 documents to read through. This is very important because imagine, right? Because LLMs, as powerful they are, they're also very resource hungry. So imagine you are sending like 1,000 documents on LLM. It's going to take a lot of time for it to pass through and get the answer. So we want to cut down, right, the amount of data we send. And also, if you're using like a cloud service, remember, right, you're paying for the usage. So if instead of sending 1,000 documents, you're sending 3 documents, that saves you time and money. So that's kind of why we involve the vector database, right? It saves 2 purposes: indexing and also reducing the search space. Yep.
And it's also for the context window. The context window is shorter instead of sending like the
that's
entire.
Right. Yeah, because LLMs have this thing called context window. What it means is they can only accept certain amount of data. What that means is you can't just keep sending data, right? So you can have to limit the data you're sending. So this kind of cuts down the context window. Yeah, exactly. So let me kind of take a second here and see if you have any questions on the overall workflow, what AllyCat is doing and kind of how we are approaching this. If there are any questions, do let me know, please. Yeah.
Yep. No. Yep.
Okay. And you can face the question on the on the Teams and all. All right. So let's keep going. So let me kind of walk you through. So what I want to do, I'm going to start showing you the code, but also I'll sort of show you the slides so you can understand the diagrams. You can what step we are doing, so we understand what the code is doing. By the way, let me share the link here. All right.
Yeah, I'll send me the link here, and I can put it in the chat.
Yeah. Thank you. So the project is on GitHub, right, AllyCat. So let me put the README file. And if you go to the page, right, and like I said, we are under Apache 2 license, as open as how open can be, and basically you can read through them and then basically follow the quick start. And if you just want to try it out, like I said, I recommend the Docker image. So again, you can read through this. It'll tell you step-by-step instruction on how to run the Docker, right? But if you're going to start developing, you're like, yeah, I like this. Let me customize this for my website. Then you can run it on AllyCat natively using Python. Yep. So, and I'll show you both. Okay. So hopefully you have the page, and I know you look at a lot of pages. So if you want to sort of remember bookmark it, just put a star, so you can always go back. Because sometimes I look at a project, I'm like, this is cool. Then I can go away, and then I come back and I can never remember the project name
all the time.
I'm like, what was it? What was it like? What's the name? Because the project names are like right? Yeah. Everyone has. So what I simply do is I put a star. Then what I simply do is right? I just go to my probe and then say your stars, right? Then I can find it. Anyway, so just just a little, yeah. All right. So here I'm actually showing you. So here you can see my terminal. I'm running this natively on my Python in Python mode. So I have the project cloned. So if you look at the project, on the top level, you see a bunch of Python files, right? And I'm going to run through them. So right now I'm running in native mode, just so you sort of see it. And all I had to do, let me also bring up my code. And what you'll see is for Python, we have a requirement.txt. Yeah, that's it, right? Just just pip install this, and that's it, right? I mean, sort of get a Python developer, pretty straightforward. Yeah. So you'll see, I'm using a few packages, and all of these are open source, right? Most of you probably recognize them. And then things like this is a data prep toolkit, and here's my databases, right? And I'm using Llama Index to help me with the processing of files. And then and then we have a little UI using Flask. Because I kind of want to create a UI just so right, when you're chatting, just just very simple, right? This is nothing to nothing fancy, just a very simple UI, and I will show you how it looks. Okay. All right, let me get going. So what's the first step? First step, we are going to download the content, right? So let me actually here. So I'm here actually. Let me actually download the content. And another thing you will see when you follow the right. So the files are numbered 1, 2, 3. So step by step. right? So you don't even need to remember, like, right? So just step 1, 2, 3, execute 1, 2, 3, and you're good. Okay. Yeah. So I'm going to follow through the instruction. I'm going to run it natively. Yeah. And what we recommend is a Python environment. I'll talk about Olama and all this a little later. So I clone the repo, and we recommend you guys have a custom Python environment. And this is the best practice, right? Because you're probably doing a couple of projects, and every project has their own dependency. So we highly recommend creating an environment specifically for each project. Yep. And you can use either plain Python or like Anaconda. This is what I use, Anaconda, because right, I just been using it and I know my way around it, so that's what I use. And we are recommending Python 3.11. Cool. Yeah. So let me make this a little clear. So as you can see, I'm creating a custom environment, AllyCat, and then all I'm doing is pip install. And you can see on my terminal, I am AllyCat. I'm using AllyCat 6 because I've been trying a few things. So every time I try a new environment, I can go like 1, 2, 3, right? So I'm at 6. So 6 is my lucky number. And then also, if you're going to run it locally, so here's the thing. We want this to be fully self-contained, meaning even the model, running a model, we support 2 options. Either you can run locally, so like nothing leaves your computer, or you can use any of the API services to run a model. There are like a bunch of them. There's Replicate, Nebius, right? There are like so many cloud AI infrastructure companies that you can actually invoke a model, right? And I'll show you both. But our default setup is local setup. We use something called Olama. Olama is basically a nice, very convenient software that lets you run models locally. Very convenient.
You don't have to pay
so this way, everything you need,
basically. Yeah.
Exactly. Yeah. There's no API keys. There's no credit cards. There's no tokens. so
no
this is my setup.
Yeah.
But, right. No credit card. Exactly. Right. But however, remember, right, when you want to run LLMs locally, you need to have a good machine. Right. So that goes without saying. If you're like a very lightweight laptop, right, right, and then not enough memory, it's not a recommended option. But a lot of us have pretty decent laptops these days, and a lot of the models these days, even the small models, are very effective. And I will talk about this a little bit later. People have an idea like you need to run this, gigantic, like a 400 billion model to get any results. No, like you can even run like a simple, like a 1 billion, even like less than 1 billion model. For something like this is very, very easy for them. LLMs have come a long way. So even the small models are very smart. Anyway, and if you want to run on remotely, so I use something called Replicate. There are other companies like Nebius, Deep Infra. There are a lot of companies. Whichever one you want to use, you can just tweak it, set it up, and this way you're running LLM on the cloud. Yeah, and I will show you that option as well. Yep. All right. So how do we run AllyCat? So once you set this up, all right, I'm just simply following the instruction. All right. So let me start with configuration. So let me show you the config file real quick. So you don't have to modify this, but I'm showing you where things are, just so you guys understand. So here are some of the limits. Like for example, if you're downloading a website, I'm capping it like 500 pages to download, right? Because we don't want to, we don't want to crawl the whole internet, right? So we are capping it out just so for experimenting, and also things like, for example, what's the embedding model we use? Again, everything I mentioned here is open source. Right now, I'm using IBM Granite model, and you can see it's only like 30 million. The size is like 30 million, right, parameters, which is a pretty small model. But I found it's doing pretty well. Let's say tomorrow there's a new model you want to try it out. That's it. You just replace this with whatever, and you can use it, right? So that's how easy it is to experiment with things. And you can see I already experimented a few, right? I tried mini LM, right? BG is small, right? I tried them all. And so right now, this works for me. It's pretty small, pretty compact, and gives me good results. Yeah, that's it. And also finally, for running LLMs, again, I'll show you both. Oh, very quickly, we are using the database in an embedded mode. What does it mean? Meaning, you don't have to worry about installing and setting up a database. Everything runs locally. So just like, if you use like SQLite databases, how the embedded databases, just a file. So right now I'm using Milvus, and you can see it's just a file on disk. And for our purposes, this is perfectly fine. Like when you go to production, you will basically go, point them to like a cloud instance instead of running a local version, right? Yeah.
So basically, what I'm putting here all those parameters like the chunking
Yeah.
size, the model that you're
Yeah.
using, all the things that
Yeah.
your example will be using, you are configuring
Exactly.
here. Cool.
Yeah. So my config is like, right, this is the right. And then, so, and then we talk about chunking a little bit. So these are kind of a reasonable values. Sometimes, you may want to play around with this, but like I said, there's only one place you just set this, and then like everyone would use it.
Yeah.
Now the final setting, excuse me, is where are we going to run our models? So you can see, right? I'm choosing local OLAMA as my default option, meaning my model is running locally. And here's a cool thing, right? When you're running locally, there are a lot of models you can try. So Gwen 3, this is kind of my favorite model right now. It's an open source model from Alibaba. When I say open source, like fully open, like Apache, I think they are under Apache 2 or MIT license. You can try them all out. So I'm also trying, right now I'm trying, Gemma, this is from Google. Yeah. And then look at the size, right? So the Gwen, this model, this is like a small model, it's only like about 500 megabytes, right? Which is, I mean, small. I mean, it's actually tiny in the world of LLMs, right? And then the models kind of go increasingly bigger. So Gemma is slightly under 1 gig. If you want to do Llama 3, it's about 1.2 gig, and you can sort of keep going, right? And then if you want to do like 8 billion model Llama, right, that's about 8 gig. So you can try them out. Now remember, the larger the model, the more resources they need. Like they consume more CPU. Ideally, you would need a GPU to get a good performance out of them. But a lot of these models run fine on GPU. I mean, a plain CPU, right? So you don't. One of the misconceptions I hear from people is you need a GPU to run any model. It's like a nice to have. A lot of these small models, like especially the small ones, right? They run pretty well on like plain CPU.
Yep.
But if you have a GPU, sure, right? They will use it too. Yeah. And that's it, right? So that's a config file. Again, like I said, you don't have to mess with this. The defaults are pretty good. So let me go ahead and start using them. Yeah. So here, let me download a site. So I'm step 1, just scroll site, and I'm basically going to crawl Alliance website, right? So let me run this. Yep, I'm in the right space. So all I'm doing is I'm just pointing to the website, right? And this one you can point to any website and then start downloading, and you will see it's going to start crawling. It's going to download a bunch of pages. It's a pretty small website. I think we are like maybe about 100 pages or so. All right, there we go, right? About 111 pages. So I actually downloaded.
I mean, the entire route, not just one site. It's navigating all the subsites.
Yeah, it'll navigate it. Exactly. Yep. So and then that's a good point. So one thing you can control, how many levels to crawl. So you can say, what, only crawl like the first two levels. Yeah. So all of these you can configure. So as you can see, I set up to 5. So like 5 levels deep, right? And then maximum downloads 500. And again, you can play around with this. Like if you have a larger website, right, tweak these settings to match your needs. Yeah. Great. Very good. So right now, if you look at this, if you look at my workspace directory, under the crawl pages, right, you will see a bunch of HTML pages and, like all the content downloaded.
Oh.
That's it, right? So that's it, downloaded, so it's done, right? So next step of what I'm going to do, so we have the files downloaded. We are going to clean up the files. Here, you have 2 choices. One is Docling, and the other one is Data Prep Kit. Both do a pretty good job. Let me just use Docling. Docling is another open source project. Very popular. You can actually parse PDF files, HTML files, and extract content. Very powerful. So I'm just going to run the Docling for now.
So what Docling mainly does?
You can see, right? It's a document parser. Yeah. So yeah. So let me show you just so if you're interested. Docling.
Yeah, because sometimes we use tons of projects and we
Yeah.
don't really know
Yeah,
what
yeah,
they do or the power that they have. We just use it for one thing.
yeah, yeah. So I'm a big fan of Docling. So Docling, as you can see, right, it's it's a pretty popular project. They have right, a lot of stars. So what do? Let's say you have documents in say PDF or PowerPoint or Word document, and you want to query them, and these are kind of proprietary formats, right?
Yeah.
So what Docling will do, it will actually go through the file, extract the content, and then you can basically export them into like a more common format,
Multiple
like a
formats.
JSON
Okay.
or Markdown or plain text. Very easy, right? So I use this quite a bit for PDFs and HTML. Like so, right now, web pages we are using HTML. I also use it for PDF. It does really well. Even if you have complex PDFs like your tables,
Images.
right, diagrams, things like the exact pictures, yeah, it can actually extract them, which is very powerful. Anyway, so Docling, definitely a project, worth your star, right? Anytime you want to process documents or parse documents, Docling is the way to go.
Cool.
Yeah.
Great.
Nice. All right. So I'm going to just run the Docling to pass my document. So all it's doing is basically, remember I have HTML right now, right? It's going to show you where we are in the process. So we are going from HTML to Markdown. Because Markdown to me is pretty simple format. It's just plain text, with some necessary formatting, so we can still retain things like paragraphs, headings, bullet points, things like that. But without any of the extra markup from HTML. So that's what we are doing. Right. So again, I'm just right. So basically, all the I'm running commands from right here, right? And you guys can do this too. Yeah. And what it's going to do, it's going to basically process. Right. So it's going to changing. So it's converting HTML into Markdown. You can see right how it's doing, right? Yeah, because remember, right now I'm only focusing HTML files, so it's kind of skipping PDFs. You can include the PDFs as well. So right now, but I'm only focusing on HTML right now, just to keep it simple. Cool. Yeah, that's it. Convert to Markdown. That's it. So if you look at our code, you'll see Markdown files created. Yeah. So, okay. So now we have the data downloaded. We have cleaned up the data, right? We did the cleanup, HTML to Markdown. Yeah. And here, we talked about Docling, right? So we are using Docling as our processor. Next step is we are going to split documents into smaller ones called chunking. Again, so let me show you an example, right? So here's an example. Here's let's say I have a document here like this. Chunking, I'm splitting them into, let's say, by paragraphs. Yeah. So here you can see the first paragraph, right, becomes one chunk. Second paragraph, and so on. Again, the reason we do this, it's easy for us to search, and also it kind of breaks the document into smaller pieces. So your search space is smaller. So you're not searching like a 100-page document. You are searching like these little pieces. So chunky. Yep. And this is important when we do natural language search. Also what we call context search, because this actually really helps us speed up. And so after the chunks are done, we are also going to create what we call embeddings. What are the embeddings? Embeddings at the end of the day are just numbers. Yeah. So remember the chunks we just created, right? Remember from the previous page, right? I have these chunks created, small segments of the page, right? Then what we are going to do, we are going to create embeddings on them. So embeddings, if you look at the embeddings, they look pretty boring. They're just a bunch of numbers, but they are very powerful. Like a lot of the natural language processing is actually powered by embeddings. So what embeddings help you do is they actually allow you to search on the meaning, not just keyword. Because remember, right? That's what we set out to do in the first place. We don't want a keyword search. We actually want meaningful context of your search. And embeddings are sort of the first step in achieving this. So what embeddings will do is they will take your blob of text. It could be anything. It could be image, videos, whatever, right? And they'll create a vector. So what I'm showing you here is called embedding. It's a vector. Because why? Because vectors are numbers, and numbers are much faster to search than text, right? So this is an optimization we are doing. So all I'm ending up with, like, imagine my original HTML file. What happened, right? I convert into Markdown, split them into chunks, and then we vectorize them. These vectors are the ones being saved into the vector database. So when you query a database, remember, like just like any other database, but this vector database is optimized to search vectors. Like if you look at the relational database like MySQL, they are optimized to search like numbers or text or indexes, right? Vector database are tweaked so they can actually search through these embeddings very fast. So slight tweak on the database, but at the end of the day, right? They store a bunch of documents indexed, and they're going to search for and then retrieve the documents. So that's it. All right. So how do we do this? So for this, here we add step 3. The step 3 actually does all of this together. It creates chunks, create embeddings, right, and then saves the chunks in the database. So let me run the step 3, right? And here we are doing all of this in one shot. All right. Let me see. Let me make sure I clean this up. All right. So here we are going to do all of these in one step. Right. Oh, so here you can see right? You can see it loaded 105 documents.
Oh, how many chunks?
But see, it actually created 245 chunks. So it's more than, right? So most of the time you're going to have more chunks than documents. And that's what it should be, right? Because remember, like each documents, large documents are getting split into chunks. Yeah. So we actually had 245 chunks from, right? If you have really large documents, like PDFs with dozens of pages, then they will split them into more chunks. Yeah. And then basically what we are doing, we are storing into Milvus. So again, you can see my Milvus is simply a local embedded database. And this is cool because remember, I didn't have to do any work setting up, right? There's no like a database username, password, none of that, right? Everything is embedded, everything is ready to go. That's what we want it to be. Yeah. So at this point, right, all my data is living in this database. Yeah. So now let's do a query. So for the query, actually, before I get there, I'm going to show you how the query works. Remember, the first stage, like on the top, is processing. So what we are doing is we have some data, we kind of walking through step by step, cleaning up, and now my data is in the database. So now we are ready to query. Yeah. So let me show you how the query works. For the query, I'm going to show you a Python web application, right? So this way, right, we can actually run the query on on a browser. And like I said, this is a very simple web app. Actually, I should tell you something here. I used Cursor AI. Cursor is the IDE to create this this website because I don't know HTML, JavaScript. I'm like, what? I was like, create me a chat
and it's
interface.
Fine. We are relying in the tools that
right.
uses AI. It's
exactly.
fine. It's fine. Yeah.
Right. It's perfect. It's perfect. Great. So let me show you this. All right. There you go, right? I mean, like I said, just right? It's just a very simple UI. You're like a text box. So let me show you this. And like I said, I'm not a front end JavaScript person. So I'm like, how do I do this? I'm like, okay, let me ask the AI.
I have done the same.
So I use one of the IDEs. Right? By the way, it's really remarkable what you can do with these AI assisted coding, right? People call it vibe coding. Okay, I'm not a big fan of the word, but I call it AI assisted coding. You can use there's so many ideas like Windsurf, Cursor, there are so many, even GitHub Copilot, right? They can generate some really.
They can break code. Your code too, but of course, if you know at least something, it's a great help. It's like a junior developer.
So they right. Exactly. So I would think of them, these kind of junior developers, which are kind of handy. So imagine so the way I like to use these is give them a task, saying do this very well defined. So I'll say create a Flask-based user interface, this and and then it will create the template. Then I can tweak a few things here and there. Then I'm up and running. Right? So pretty awesome. All right. So here's a very simple, very straightforward chat interface. So let me ask a question. Like I'm gonna say, what is AI Alliance? All right. So
And the model
hopefully, there we go.
is just using the information from the database. I mean, it's not comparing.
Yep.
I mean, it's not an agent, right? So it's not saying, hey, if I know the answer,
Right.
I can answer. If I don't know the answer, I go to the documents. It's like it's always going to the documents.
Yes.
It's always doing
Yep.
the retrieval.
Exactly.
Yep.
So right. Yeah. Exactly. So everything. Yeah. So basically, the model is constrained to the context.
Based on the
So
context.
what does it mean?
Yeah.
Meaning like only answer the question from the documents provided.
Yep. Awesome.
Right. Exactly. So, and by the way, so you can see where's my thing? Yes. Right. So like AI Alliance, right? So for 2.3 seconds, that's not bad, right? Now, so what's happening, right? So remember, so can I understand what's happening behind the scene? So when I'm running a query, let me show you here. So I'm asking a question, like what is AI Alliance, right? So first we hit the database. We go and say, okay, here's a query. What pages, or what I should literally say chunks, or what chunks have this information? So now the vector database will search through, its embeddings and say, oh, okay, yeah, I see a few documents matching your query, right? So it's going to give me that. Now remember, this is not the final answer. So you had to think like the old school, like Google days, right? Remember when you go and do a keyword search, you get a bunch of pages, a bunch of links, right? That's exactly what you're getting, right? So I still don't have the answer. So these 11 documents, remember, right? We talked about this. Like, let's say I had 100 pages indexed. Maybe only 2 pages have the answer. So I'm getting the 2 pages back. So now these 2 pages and my question, right? So that's my query, my question, and the pages are being sent to the LLM.
Yeah.
So LLM reads through them and say, okay, I get the documents. Okay, here's a question. Okay, what's the answer, right? So the LLM does its thinking, and it's going to give me an answer back. Now, in my case, my LLM is running locally. So I'm running a smaller model, right? Just so you know, it doesn't tax my machine too much. But remember, you can, based on your machine capacity, you can run a decent model, right? So again, bigger the model, they have more intelligence, right? But even a small model, I'm running a 1 billion model. Let me show you here. So I'm running in my config. I'm running Gemma 3, 1 billion, right? So it's slightly under 1 gig size, which is just fine. Yeah. But you can try these out.
Parameter, which is
right, exactly, right?
Fine.
Yeah. So, and if you go to Olama website, right? I mean, they will give you the models, that you can download. For example, let me actually show you here, right? So, like for example, I'll just show. Let's look at Gwen 3 because this is like an open source model. So if you look at Gwen 3, you see all these different sizes, right? So the smallest one is, like 0.6 billion, right? So like almost 600 million, right? And you can look at the sizes. Like for example, let me show you here. Right, so you can see, right, 0.6, and then look at the size, right? So the 0.6 model is about 500 megabytes, right? Which is pretty good actually, right? And as you kind of keep going down, right, you can see the size incrementing, like 1.7 billion, 4 billion, 8 billion, and of course, right, the model size is going to increase, right? So that means you need more RAM, like more CPU to run this. And then you can see, right, the largest one is like 235 million, right? So that's a pretty massive model. Look at the size of the thing, right? It's like 150 gigabyte. So if you want to run this, right, you need, if you want to run it in CPU, right? I mean, at this point, you probably need like a GPU, I think, right, to run an accelerator to run this. But yeah, but this model is a pretty amazing model.
And how do you think? I mean, from your experience with using the RAGs, because we have SLMs or models like with very short amount of parameters, like 1 billion, 7 billions, or 14 billions, and we have those huge ones. Do you think that most of the time you can fix or you can solve all the problems on RAG or the answers using SLMs, or or do you think that in any particular scenarios you probably may have a big model. What are your
Yeah.
thoughts about it?
Yeah, that's a great question. To me, like as I've been sort of playing around, my sweet spot has been sort of around the 8 billion mark, right? Is reasonable. Like you can see the size about 5 gig, right? So it's a pretty reasonable model. To me, and again, this is kind of a, how do you say, by using a few of them and kind of under looking at the sizes and the query responses. Yeah. Around 8 billion, you can pretty much, how do you say, it's a pretty safe bet. You'll get pretty decent answers, right? And they are not too, too large that you need like a special setup. It'll run on your laptop just fine. So to me, that's fine. But like I said, in this case, like I'm using a 1 billion model, and you can see, right, it's doing pretty well. So what I always recommend is kind of try a few things out and kind of see which one works for you. Let me do another query here, right? Let me just go back to my thing and then say, so what are upcoming? So I'll just say what are upcoming events. So let me see, right? So there you go, right? So this is interesting. Remember, right? In our page, if you go to the events page, right? We have a lot of events listed, right? So you can see, right? It's actually, it's only grabbing the future events, right? It's so right, so which is pretty good, right? So, so what I'm asking, like you can see, I'm just asking like natural queries, right? So I don't have to figure out like what the keyword is. I just ask the question, right? Let me ask one more. I can say, how do I join the alliance, right? So you can say, submit the membership form and invite, all that. Yeah. So as you can see, very easy to use, right? And the answers are pretty good quality. And then I'm using like a pretty, you can say small model, like 1 billion parameter model. And you can see it's doing pretty well. So I designed the AllyCat to be like, you can try them. Like, for example, you say, you know what, I'm going to try like an 8 billion. Sure, right? Like there's only one line you have to change and then try them out. Yeah. So very flexible. And also hopefully very useful because now, your website has a search that is just not a keyword search. It's actually, you can chat with your website. Yeah.
One more question. This is great, Sujee. Awesome. Thank you.
Thank you.
One more question. I mean, you said that you have these two options. One is the Python or the Python, and the other one is the container. What do you exactly have on the container? You have there's a container that actually runs and gives you an UI, or is a way that you can interact with the container somehow?
Very good. Yeah, actually, let me show. Yeah, that's a great question. So let me talk about this a little bit. So very quickly, I want to talk about the pros and cons of running the models locally versus in a cloud. So remember, we are by default we are defaulting to local mode because, like I said, we want it to be like just completely self-contained. So you don't have to go sign up for a service, like the API keys and all that. But also, if you're going to run larger models, right, there's a case to be made to run on the cloud. But like the cloud services, they have a lot of models available. You can try things very quickly, and you can run on GPUs. You can run big models, right? So there's a lot of flexibility there. But you're also paying for the usage, right? So the more you use, more you pay. Now, if you're running locally, right, you already made the investment. It's running on your local hardware. So depending on your use case, you can choose one. Like I had clients who told me, you cannot use any API. Like you cannot use like OpenAI, ChatGPT, and all that because they're like, our data is sensitive. We don't want our data leaving your machine, right? So there could be sensitive use cases. You want all your data to be right there, not go to some cloud service. Yeah? So depending on your use case, you can choose one or the other. Yeah? So again, here's like a kind of pros and cons. Like a lot of people like, to run on the cloud is very easy. Just sign up, get an API key, and that's it, right? You're up and running. And there are a lot of models. You can even run like pretty large models like that you may not be able to run on your laptop, for example, right? But there's a privacy concern. Your data is being sent, right? So you need to be mindful of that. And there are a lot of choices. Here are the few I've used, right? And they are very easy to sign up and use. Yeah. If you're running locally, remember, everything's running locally. You need to make sure you have the hardware to support it. And there are a lot of local runtimes that you use. So the Llama CPP is kind of like a funky name, but basically, a lot of local runtimes rely on Llama CPP. So this is sort of the engine everybody ends up using, but it's kind of a little low level. So like a lot of the tools like Llama will give you like a high level, right, interface to use this. But a lot of people, and I use Llama CPP, it's fine. So this is a sort of the actual core engine. A lot of the other tools rely on. But yeah, right. So you can pick your software to run this. And then, like I said, right, so I mean, here's an example of replicate. So again, you can see, right, I'm showing you Llama and Granite models. You can see their parameters, right, and you can choose them. Like, for example, you can say, oh yeah, I want to run the 8 billion model. That's it. Or you can say, I want to run the massive model that is like, 4.5, 405 billion, right? Kind of see, right? Yeah, just one line change, and you can run it. Yeah, and so. So I'm a big fan of Llama. So right, it's very easy to use. Right, so I'm doing, it's like a Docker, right? You're saying Llama pull the model, right? So let's say this is the model I want to try out, and then Llama run model. That's it. Yep. And then the model is running locally on your machine. Like, for example, let me show you what I have. Like if you look at my machine, I may have Llama list. So these are all the models I have downloaded, right? You can see, right? I have Gemma, like 1 billion, 4 billion. You can look at the sizes too, right?
Yeah.
And then like I've been actually really running Gwen 3 is like my kind of latest favorite, right? It's actually pretty good. Gwen 3 is also what we call reasoning model, meaning like it's a called thinking model. So it actually do reason about like your question and answer, right? Which is very good. Anyway, so there are a lot of choices. And this is why I'm a big fan of open source, because now, all these cool technology, all these cool models, you can try them out, right? Which is pretty nice. All right. So that's Llama if you're running locally, and that's what we use by default. So yeah, we asked about the questions, right? So, I'll sit through this. Yep. So let me also show you Docker. So let's say you've been developing, right? You're like, okay, this is good. Maybe you just tweaked a few things. How do we deploy? Because we want this to be easy to deploy as well. Because let's say, you have a website, you just want to like deploy this on a cloud. So the way we deploy is Dockerizing the entire stack. So in our Docker, you have your code, you have all the libraries installed, just like any Docker would. But also, I'm also packaging the vector database, right? So if you look at the Docker container, it's completely self-contained. It doesn't need to download anything, right? It does everything it needs. It even has the Llama, the models. So let's say you're trying like Llama, Llama 3, Gwen, whatever the model, you package it all up into a Docker container. That's it, right? So then what we can do, we can deploy the Docker to pretty much any cloud service, right? The Google Cloud, right, OPR, whatever, right? And then it just runs, and then you just query the Docker. That's it. So very easy to use, and all the code, like if you look at our, right, I'll talk about this a little bit. So deploy, right? So it's got the deployment guide.
Oh, cool.
And then we talk about, how do you package them up into Docker and run this. Let me show you a quick Docker, right? Let's say if you want to run the Docker, let me show you how you would run this. Let me run this using Docker. Yeah. Let me show you how easy that is. I'm going to stop this for now. And then basically, all I'm doing, just run this. All right. So I'm going to say, let me actually copy the command so you actually see it. So you're going to say Docker run. Right. So we are doing the port mapping, so the UI, I can access the UI.
And that's pulling from your
and that's it. That's my. Yep, exactly. Yeah, so right now, yeah, exactly. Right now, it's checking. So let me actually show you, right? So right now, we're on this. All right. So again, I have Llama installed, so it's starting locally, right? And then, once you're running, then you can just say, Python, crawl website, right? Then you just go through the same thing. That's it. So now you're running within Docker. You don't even need to have Python environment set up. I was working with somebody. They had like an old Python or something, And they were like, oh, I need to kind of reinstall the whole Python. I'm like, no, you don't have to do all this. Just run this Docker for now, see if it works for you. And they did, right? So the Docker image, as you can see, right, everything is completely packaged right here.
Okay.
And you run this.
Okay, so you go inside the container and you run everything. You run the Python,
Exactly.
whatever.
Yep.
Cool.
And then also, so I'm using Docker as a two modes. One is to run, is the other one is to deploy. Because at the end of the day, whether you run in Docker or run natively, you need to package it up to deploy. And we have scripts basically to actually help you deploy this. Let me show you something. This is interesting because I spent some time on this one. So you will see like a requirement.txt file specifically for, so by the way, there's a Docker file here. Yep, right, Docker file. So, pretty straightforward. So, it does, install all the libraries we need, right? Setting up a Python environment, installing my Olama, right? So everything is Dockerized, yeah. And some people ask me, why do you have two requirement.txt file? One, one here and one Docker. So this is something I spent some time, because remember, we are using a lot of models. And when we use these models, they rely on basically a software called PyTorch. This is pretty much the underpinning software that all the models rely on. Now, PyTorch comes in two flavors, CPU and GPU. Right? GPU means right? They run much faster. Now, by default, they install all the both options, CPU and GPU. And the GPU libraries are pretty large, right? They're like several gigabytes. They add several gigabytes to Docker. So what I'm doing right now is I'm saying, hey, you know what? If I'm going to just deploy on like a regular hardware, right? I don't have a GPU. Why install all the packages?
And they are heavy.
Because all it does is, right? Right? You've seen them, right? They're like multiple gigabytes in size, and it really bloats your Docker. So what I'm doing here is, the reason I have two files, one for Docker and one for your laptop, is excuse me. So you can see, right? I'm using the CPU version of PyTorch, and this is a kind of a smaller package. So we sort of did all this optimization, because making sure, because you don't want to deploy like a huge Docker, right? That's inconvenient. You need a lot of memory, right? A lot of CPU. So we tried all these best practices to make sure you have a pretty tight deployable container. And that's it. You just run the Docker, Docker build, and that's it, right? It'll set up everything for you, including code, library, and even like things like model serving, like Olama and everything.
Cool.
Because to me, right, let me show you. Oh, there we go, right? So here I'm deploying to Google Cloud. Just 3 steps, right? Basically, so I have AllyCat, right? And I'm deploying to Google Container Registry. So you have to tag it that way. And once you push to Google Cloud, all I'm doing is a gcloud.run, right? And then just give it the image, right? And you can specify like CPU, memory, and all that, right? And that's it. Right? So what they will do is they will download the image, spin it up. You can even set it up so it scales automatically. So if you're getting a lot of traffic to your Docker container, they will spin up additional Docker containers. Pretty nice, right? So if you think about this, this is pretty nice, because to me, I done my work. I did the whole development, download, index, save. My model, everything's in a Docker container. So now just deploy. And I want the cloud platform to take care of scaling, scaling up, scaling down, right? If nobody's querying, I can shut it down to save me money, all that. And I had pretty good luck with this. You can just leave it running, right? If there's no request coming in, they will shut it down. And when a request comes in, they will spin it back up. Yeah.
Oh,
so it's pretty convenient. Yeah. So
awesome. All right.
So how are we doing on time? Okay, I think we are doing pretty good. And I'll take some questions, but let me just quickly, actually, why don't we take some questions, right? If any questions, Easy, if you have any, let's go through them.
Yeah, I do have, actually, I mean, more than a question, is a comment, and something that we should work together on this, because all of these components that you build can actually run on Opia as a platform, right? So to use multiple components and everything, because it's actually the same components that you are using. So we should be,
That's right.
PIA helps you on the deployment, right? When you are building at scale, like, but it's more like
Yep.
a production when you have a big database, when you have not just everything in one content, when you have everything is splitted in a production grade, or it depends on the
Yep.
use case, right? But I
That's
think
true.
that for that use case, we
So
should
that's
start
how
working together.
that's how I would envision the like. So right now, this is basically the prioritizing convenience.
Yeah.
Like everything's in one, so you don't have to worry about this. Now, but you're right. In production, you can imagine like, vector database is its own container, right? Its own service, right? Olama, like the model serving its own service, right? So all of these components will be split up into services. So you have like a production grade deployment.
And it's also, again,
Oh,
depends on the use case. Sometimes it's better to have everything just in one package, everything
exactly.
put it there.
Yep.
But some use cases probably you cannot put in one container because it's a huge solution.
Right. Right. Oh, by the way, just remember I was showing you about the container size. Check this out, right? So.
Oh yes, I
So
was going
this
to
is
say that. Like every
right.
time, if you deploy, if you download, if you do the pip install by mistake the PyTorch, you will see this. Like, man,
Yes.
why is
Right.
so heavy?
So I mean, it's almost like so that the CPU version is like let's say 3 gigabytes. The PyTorch like GPU is like 10 gigabytes because it downloads so many libraries. And remember, look, I mean, if you're running in a GPU runtime, by all means, right, you need that. But if you're not, then that's just additional weight, right? You're not using
memory,
space,
right?
Everything.
Yeah, it's crazy.
So we done, right? So my principle for AllyCat is this. It's simple, but not simpler. What does it mean? Meaning like it's simple enough so you can up and running, but it's actually useful enough, right? So it's not like a toy project. We want this to be actually something people can download and use and contribute. And so that's another reason, we sort of made it easy to use and deploy. And also I'm also, because I like to experiment a lot, you know me, right? So for example, I'm like, okay, which embedding model should I use? Which LLM I should use? So we also made it like so easy to kind of swap things out and try them out. So for me, right, you've seen my setting, like for example, I showed you my config file, right? This is sort of the, this is pretty decent. You can start with this, but like I said, you can experiment with this any way you guys like, because it's all out in the open, right? Let's say you want to try out new embedding models, new LLMs, right? By all means.
That's amazing. That's amazing.
So we want this to be pretty extensive.
Right. So how can people contribute to this if people would like to be part?
Yes. So let me talk about this. So you can download this and start using it. So it's on GitHub. So hopefully, we gave you the link, right? So you can go to GitHub, just follow the instruction, right? You can actually. so if you do like a project, do give us a star, because it helps us to kind of promote the project and get more visibility, right? Here's how I would use it. So you're like, okay, this sounds interesting. I want to try it out. Download the Docker, right? And just try it on your side. Kind of see, is it working, right? Is it doing a decent job? And if it is, and you're like, okay, yes, I like this. Now I want to, develop for it. Maybe change out a few things. Then you can move to the Python version.
Maybe change the UI.
And if you end up adding, or maybe change the UI, something better, right? Yeah. Hey,
I'm the same as you. I mean, I'm not doing
any
judgment. I would do exactly the same.
Right. So, and then you can say, hey, I think I'm adding this cool feature, which I think others may be useful. So give us a pull request, right? Now we are very open to your issues and your suggestions. Because remember, we want this to be useful, right? We don't want this to be like another toy project. We actually want this to be a useful project, and we welcome your changes and suggestions. So check it out on GitHub. I think we gave you the link, right? You can open issues, you can send us requests, you can ask questions in the discussion forum, and we are monitoring, and we're happy to answer and help you out.
That's amazing, awesome.
So that's it. So this kind of a like maybe take a screenshot, take a picture, whatever you guys like. And if you like to get in touch with me, right here are all the methods. You can email me, Twitter, Blue Sky, usual.
Yeah.
All right, guys. So that's it. So hopefully it gave you a sense of what we are trying to accomplish. Hopefully you found it useful. We welcome your feedback and input. Right. So do check it
Yeah,
out.
awesome. Thank you, Sujee. This is great. This is awesome. So thank you for you. Yeah, now it's just both of us. Thank you for your time. I mean, that was a great. Totally agree with the part that some projects we need to get the structure in order to get to people to use it, even if they because some
Yeah,
people use it, but they don't give a star or they don't clone it or they don't make people know that hey, I
yeah,
was
yeah,
using this project. Also
yeah,
improvements. There are tons of improvements or whatever that you
yeah,
can do it better. Not better, but I mean that to add
yeah.
new functionalities, new things. I
Identity.
can imagine this in the future probably
So,
embedded in a web browser
uh,
once the browsers could host containers.
right, exactly. I mean, I just heard from somebody yesterday. He said, "Oh yeah, hey, I just saw this project. Somebody sent me a link, and I used the Docker. I was up and running in 5 minutes."
Totally. Yeah.
I was like, "Yes, right. That's what we want, right? We actually want people to actually
Yeah.
use it, right? Because I mean, I'm sure you went through easy like some projects. The setup instance is like 200 pages long. You're like, oh my god, like like I will never start using it. Like I'm still spending time setting up
Yeah.
the
And the
project,
process and what it
right?
does at the end is very simple and very easy. That I mean,
And you're like, oh man, I went through all this just to,
exactly.
you know what I mean? Yes, it's a
Exactly.
huge letdown, right? So and you've been through this, I've been through this,
All
everybody
of
been through.
us.
I'm like, you know what? No, like nobody has time for this nonsense anymore, right? We just need to be like simple, to the point, and up and running in 2 minutes.
Oh, that's
That's the
amazing.
idea.
That's amazing.
Yeah.
That's amazing. All
Cool.
right, Sushi.
I
Yeah,
I
sure.
love
Go ahead.
to. Yeah, I love to explore the idea of turning this into an
Yeah.
OPR componentized, right? Yeah, I think that's a very logical next step. I love to talk to you about this.
Yeah,
Yeah,
we should do some joint work on that. That's to mix
please. Yeah,
both projects because they are totally applicable because there are similar things in
yeah.
different with different angles. So it's amazing. So I mean, so if we have some time, because that's a problem that we don't have time usually. But
It's
if
always time,
we
right? It's always time. Yes, I know. Yeah, yeah. It's always time.
but
Yep, yep.
we should start working on that, and why not? We can have probably a session in the next 2 or 3 months. I'm saying months because that would take probably 2 months. Not because the time it takes, because the time that we have available.
Yeah.
And same
Right,
thing. I mean,
right.
I'm also working with
Yeah.
the EPK folks to have OP and so on. So
Oh,
this
yeah,
is
yeah.
yeah, there's a lot of collaborations, and this is the
Nice.
beauty of open source, right? So they are all open source projects. They all can collaborate, can work, and yeah, and this is amazing. So. All right. Again,
Perfect.
thanks,
Okay.
thanks, Sujee. Thanks for your time. We appreciate your time. For the audience, we will be posting this on YouTube and LinkedIn. All the links that Sujee shared and also his networks, we will be sharing everything, also the project. And thank you for your time. Thank you, Sujee. It was great having you. And for those of you that attended and stayed until the end, we'll see you in probably a few weeks, probably a month. But we will post in our next session soon. So thanks so much
Yep.
and take care.
Thank you, guys.
Thank you.